In this video, we're going to do another combustion example where we're going to follow that four-step process that I've shown in my other videos, where first we're going to balance just the carbons, then we're going to just balance the hydrogens, then we're going to balance the oxygens, where if we need to use a fraction, that's going to be okay. And then step 4 says if you used fraction in step 3, multiply everything by 2, and we will end up using step 4, spoiler alert, for this chemical reaction. But first up, it says predict the products and balance the reaction when C9H19OH combusts with oxygen in the air. Okay, so the products are always going to be CO2 and H2O. If you've got a hydrocarbon with other elements in it, like nitrogen, then the products will be a little bit different. But if it's just a regular hydrocarbon containing carbon, hydrogen, and maybe oxygen, you're always going to be making CO2 and H2O. So to start off, we'll write that hydrocarbon formula. So C9H19OH. And then oxygen in the air is referring to diatomic O2. And I'll just leave off the physical states this time for this video. And we're making CO2 plus H2O. Okay, so step 1, just balance the carbons. So I see that we have 9 carbons on the left side. So what number do we want to put in front of CO2? We'll put a 9 right there, and that'll give us 9 carbons on each side. Next up, just balance the hydrogen. So I see over here we've got 20 because we've got 19 plus that 1. So that means I want to put a 10 right there. And that will give me 20 hydrogens on each side. Okay, so step 3, this is where it gets fun. Balance just the oxygens, so we're going to put a number right there, where if it needs to be a fraction to force it to be balanced, then we'll use a fraction because we have our step 4 where we're going to basically get rid of the fraction. Okay, so checking what I have on the right side, I've got 9 times 2 for the carbon dioxide, so I have 18. And then 10 from the water, so that gives me 28 oxygen atoms on the right side. So that means I need 28 on the left. So I want 28 oxygens. I've got 1 already from that hydrocarbon formula. So that gives me 28 minus 1 is 27. Now, oxygen being a diatomic, I'm going to go ahead and divide by 2. Now, 27 is an odd number. 27 divided by 2, that doesn't give me a whole number. So this is the fraction that I'm going to put in there. I'll put 27 halves. Now, we can't just leave it like this. When we're balancing chemical equations, we're not supposed to have fractions. So you cannot just leave this as your final answer. So what we do, step 4 says if you just use a fraction, which we did, you multiply everything by 2. So what that means is now we'll have a 2 in front of the hydrocarbon. This 27, oops, didn't want to do that. The 27 halves just becomes 27. The 9 becomes 18. And the 10 becomes 20. So again, balancing combustion reactions can be very, very challenging. But if you kind of follow this 4-step process, it can be very, very easy. And I hope this was helpful. We're done.